Hi, this is an attempt to present our final project as part of the Data Semantics online course. We are a team of two members. I am Sanjana Pokale and my teammate is Parth Patel. For the final project, we decided to do an active Kaggle competition about predicting house prices using some advanced regression techniques. So, as mentioned, the main objective or the problem statement of this project is to predict the house prices of a house based on different features associated with the house. For instance, I would want to guess the price of a particular house given which locality it is in, or depending upon the different features like the number of bedrooms or the number of bathrooms that are there in the house. I would want to know what the optimal price that I can pay for a particular house. Like I mentioned, this was an active Kaggle project, and the entire data set was also adopted from the same source. Before we dive into the exploratory data analysis, I would like to give a brief introduction to how the data actually looked like. So the data was present in the form of a CSV file. There were two files, for the one for training data and one for test data. Each of them had close to 1400 rows and about 81 columns. 80 of those were independent variables. That those were actually the features depending upon which we would predict the value of the sale price, which would be our dependent variable. And the data types of these columns were both numerical and categorical. We are trying to predict the sale price of a particular house given the independent variables. One of the techniques that we have used for this project would be regression. And as we know that for regression models to work perfectly, it is essential that the distribution of the dependent variable is normalized. But as we can see in this graph, that the sale price is evidently skewed, and we need to apply some log transformation for it to be able to come into a normal distributed way. This is a heat map which shows the correlation between the different features that are present in our data set. It is observed that some of the features have significantly more impact on the prediction or the predicted value of the sales price when compared to the other features. And on the right, there are a few scatter plots which explain the highly correlated nature of some of the features, and we can see that they are quite positively correlated. And these features will be the garage area, the total basement area, and likewise.
For the data pre-processing part, we initially handled the missing values. So we used Python as a primary coding language, and in Python we use Pandas library to manipulate the data. So for handling the missing values, we went about in a couple of ways. So one was like if the value or if the column had numerical values, we replaced the missing values with either the mean or the mode. The idea was if the column has too many outliers, we go with the mode, and if not, then we go with the mean. We also did some dummy value coding for the handling missing values. For example, consider an example of a column called the presence or absence of garage. So we observed that this column has too many null values. So we replaced all the null values with an assumption of no garage. We also did some ordering in the data. For example, in a column called the month sold, which indicates the month in which the house was sold, we replaced the textual data like the name of the month with the numbers. So January was replaced with 1 and December with 12. We also eliminated the outliers. The following are the IDs of the outliers which were eliminated. I would like to mention that all these activities were done after concatenating the training and the test data set, just like in order to get uniformity across the complete data. Following is a sample of the feature engineering we did. We added new features, then we rewarded good qualities, and then we penalized the bad qualities as well. For example, on the right you can see a sample code snippet which checks the value for the overall quality, and if the overall quality is less than 5, it creates a new variable called the overall quality poor, and sets it to 1, and all the remaining values to 0. Similarly, we create a new variable called the overall quality good, and then we give the value 1 for all the overall qualities which were above 5 and 0 otherwise. These are the data pre-processing. This is a sample data pre-processing for one of the columns called neighborhood. So you can see there are the box plots and the count plots for the neighborhood. Now we coded like one for all the neighborhood areas which had subsequent number of counts for the house sold. For we can see like around 3 columns which had like good amount of house sold. So we coded that as 1, and we coded the other values as 0. Following is the methodology which we use for modeling. So the basic methodology is regression, which, as we know, usually takes in consideration a number of independent variables and assigns some weight coefficients to them, and based on which we get a value for our dependent variable. Considering the complexity of this problem, we decided the linear regression wouldn't be sufficient or wouldn't be efficient as such for obtaining a good output. So we went in with lasso regression, which is an advanced form of linear regression. The idea behind lasso regression is to do an L1 regularization, which basically means adding penalty, which is equivalent to the absolute value of the magnitude of the normal linear coefficients. This is the mathematical format of that. So it's just the normal linear regression objective, that is without regularization, and then adding an alpha, which is an alpha value, and a product of the sum of absolute value of the coefficients. Now for choosing the alpha values, we did some iterative processing, and the best evaluation, again, the best evaluation strategy for lasso regression is an RMSE value, which tells you how good your model is. So for the different values of alpha, we obtained the best RMSE value at an alpha value of 5.5 e minus 4. These are the results of our project. As mentioned, we got the best RMSE value of approximately 0.12, and then we submitted our output file to the Kaggle competition, and we obtained an 82nd rank out of approximately 2600 submissions. Again, Kaggle gave us a public score of 0.11523. Thank you.